right, here we go. Any questions on the homework? Questions on the homework? All right, let's see, 1 through 19 all, I only call it the even ones, let's see, number 2, the slope is for A is 0, and the slope for B is not defined because it's a vertical line. Number 4, the slope is 7/3. Number 6, the slope is 1/5. Number 8, turns out that's a vertical line, so the slope is not defined or undefined. Number 10 is -9/2, -9/2. Number 12, it was 2 parts. It was slope and then the distance of the segment. So you had to use both the slope and the distance formula. The slope is -3 and the distance is 2√10. Number 14, the slope is -2/11 and the distance is 5√5. Number 16, let's see, what does it ask? It says, sketch a line and find the coordinate of two. There's a lot of answers for 16 and 18, so I'll have to look at what you wrote down. Okay, that was it. We are getting very close to the end of the book. In fact, what you see in front of you on this calendar right here represents all but 2 weeks of the final class. Or so if you could imagine 2 more weeks here, that final week right there, the second to final week right there, we're going to take the chapter 13 test, and then we're going to start semester final review. We might do one section of chapter 14. My goal every year is to make it through at least chapter 12. The fact that we will make it through chapter 13 into 14 is a good thing. Chapter 14 is a nice chapter, but it's not a requirement. And then that final week there is going to be Monday through Thursday. Excuse me, Monday through Thursday semester finals. Okay, here's your homework. There's our last algebra review. Our last algebra review of the year. I'm going to warn you, there are no instructions in the book of how to do this. So if you have good recall from algebra and how to deal with exponents, which is what the review is on, then you'll be fine. You could probably do your homework right now. If you don't have a good understanding from last year in pre-algebra for exponents, then you need to pay attention. There's basically 6 rules to deal with exponents that they will ask you questions on, and I will go over all 6 of them, but I will probably do it at a pretty fast pace because this is a review. This is stuff you're supposed to already know how to do. If you are live, make sure you ask questions. Here we go. So exponent review, there are 6 exponent rules. All right, let's see what the first rule says. Well, the first rule just deals with just general exponents. What does it mean? How do you simplify them? Okay, so here is, in math, people always like to write things. Why don't they put numbers instead of variables? Well, that's because we want to make the definition very broad, so it would apply to any numbers. All right, so here's how it's generally stated, that if you have a to the m power, it is what it's called exponential form. An exponential form is a way of showing repeated multiplication. If you remember, if you had a good algebra teacher, with those of you that had me, hopefully you consider me as a good teacher, but I told you that the what's in blue there, the bottom number, the larger of the 2 numbers, and I don't mean value-wise, I mean the physical size, is called the base. And the base is that number that's being repeatedly multiplied. The m there, and it should be a little bit smaller, and it's to the upper right, is called the power or the exponent. And that tells you how many times to multiply the base. So I'm pretty sure all of you have had this instruction before, that the larger number, the one on the bottom, is called the base, and the other number is called the power or the exponent. All right, so it's a way of showing repeated multiplication. How does that work? So here's an example. And we got a base of 2 and an exponent or a power of 3. We would read that as 2 to the 3rd power. The 2 is your base, so that's the number that's being repeatedly multiplied. How many times is it being multiplied? Well, that's what the power gives us. The power tells you how many times that the 2 is being multiplied. Not 2 times 3, but 2 written 3 times. See that? It's 2 written 3 times, not 2 times 3. Well, it's repeated multiplication, so we put multiplication symbols in between. And to simplify it, we simply, well, we do the math. 2 times 2 times 2 is 8. 2 to the third power is 8. It is not 2 times 3. So I'm going to say it for 50 times. It is not 2 times 3. It is 2 written 3 times. There are a couple times when it literally is the base times the power. These are coincidences. These are not rules. It's just a coincidence that 2 to the second power is the same as 2 times 2. It's 2 written twice. But generally speaking, 99.999% of the times, it's not the base times the power. It's the base written how many times by whatever the number that power is. All right. So hopefully your math teacher, if it wasn't me, made really clear about that. That, by the way, that is the most common mistake, is they'll simply do base times power, and that only works in very, very, very few cases. Some quick examples. Let's see. The base is 13. The power is 3, so I need to write 13 3 times. Do that math. The base is 13. I need to write it, well, 1 time. All right, no math involved there. Here's the first tricky one. If there are parentheses involved, the base includes the parentheses. I'll say that again. If there are parentheses involved and an exponent, and the exponent is outside the parentheses, then you need to include the parentheses when you write that 13 3 times. You're like, well, that wouldn't make any difference. Well, that wouldn't make any difference here, but it will make a difference when there's negatives involved. All right, in yellow there, when you expand those out and rewrite the base however many times the power is, that's called expanded form. The original form is called exponential form, by the way. All right. When you actually do the math, that's called simplified form. So let me explain that one. So we have 3 to the second, or 3 squared. That means not 3 times 2, but 3 written twice. So we expand it. We write it in expanded form, 3 written 2 times. And then when we do the math, that's called simplifying. Tonight for homework, it's going to probably say simplify. Simplify means expand it from exponential form to expanded form to doing the math. 3 times 3 is 9. I'm making this way more complicated than it probably needs, just so that you understand the terminology. When it says simplify, they're asking you to do the math. To do the math, you have to expand it. Probably most of you would do that in your head, and that's fine. The big but here is that negatives cause big problems. I mean, big problems. There are 2 cases. Notice I have a vertical blue line there. I've got the case where the negative is, it says on the outside, it's without parentheses. And then I have a case where I have parentheses and the negative is on the inside. These are 2 separate cases. We're going to get 2 different answers for both of these. All right, let's see what happens. When the negative is on the outside, since we could read that as subtract 3 to the third power, well, you don't do subtraction before you do exponent. Subtraction comes last. So technically, I need to do exponents first. So the base is not -3, the base is 3. So I would have to do 3 to the third power and then tack on a minus sign. So it turns out when there are no parentheses involved and there's a negative number, the answer is always negative. The answer is always negative. No parentheses and a negative, doesn't matter what the power is, the answer is always going to be a negative. Because think about it, -3 times 3 is -9, -9 times 3, -27. Doesn't matter whether there's an even or an odd number of powers, the answer is always negative. Compare that with when the negative is on the inside. All right, negative is on the inside of a set of parentheses. We said from the previous slide that we need to include the parentheses in our base. So that's parentheses -3 written 3 times. Notice the exponent here is odd. Watch what happens. So -3 parentheses written 3 times. Well, we get the same answer. So when the power parentheses involved, negative inside, when the power is an odd power, yeah, we're going to always get a negative number. Why always a negative? Well, negative times a negative is a positive. Positive times a negative is a negative. Okay. Notice, though, what happens when we have an even power. Negative on the inside, even power. Watch what happens. Well, I'm going to have 4 parentheses negative 3, right? So negative parentheses negative 3 written 4 times. Well, watch what happens. A negative times a negative. Let me indicate this one. These two multiplied together gives me a positive. Well, positive times a negative is a negative, and a negative times a negative is a positive. So final answer is positive. Negative times a negative is a positive. Times a negative is a negative. Times another negative is a positive. Hopefully you followed that logic. I know I said that kind of fast. Here's another way of thinking about it. Well, let's see. These two negative, multiplication is commutative. I can multiply them in any order I want. These two negatives give me a positive. These two negatives give me a positive, and a positive times a positive is a positive. There's another explanation. Bottom line, if the power is even, it doesn't matter what the number is. If it's even, you're always going to get a positive number. The power is odd, always negative. Power is even, always positive. There's a lot going on with this slide. I mean, a lot. The sooner you commit this to memory, the better off you'll be in higher level math. You'll be using this all the time next year in Algebra 2. If you take pre-calculus your senior year, you'll be using this all the time in pre-calculus. If you take calculus, you're going to be using this all the time in calculus. No parentheses, and in the negative and powers, answer is always negative. With parentheses, it depends whether the power is odd or even. Odd, it's negative. Even, it's positive. Whew, that was a lot to say on that one little thing. All right, so let's just see what this turns into. Let's see, negative on the outside, the answer is always negative. 2 to the third power is 8, so we get negative 8, negative 8. Ooh, look, the middle one, negative on the inside of the parentheses, we have an odd power. So the answer is always negative. 10 times 10 times 10 is 1,000. So we get negative 10,000. What? 10,000, 1,000. I said that incorrectly. Negative on the inside, but an even power, the answer is going to be positive. Negative 6 times negative 6 is 36. Questions? Questions? Okay. We're on to, I said there were 6 of these. So now we're on rule number 2. Rule number 2. It turns out, and we've used this year a couple times, anything to the 0 power is 1, with one exception. 0 to the 0 power is undefined. So if you ever have 0, you won't this year. 0 to 0, this is called undefined, UND, undefined, undefined. But anything else to the 0 power, by definition, is 1. By definition is 1. Now, if you had me for algebra last year, I explained why that's the case. I'm going to hold off on that explanation until we get to the division rule, and then I will come back to why anything to the 0 power is equal to 1. But numbers to the 0 power are 1. Variables to the 0 power are 1. Like, in fact, if you have any exponent or any variable to a 0 power, you can get rid of it and just write the number 1. I love this question. I usually have it on many tests. This is a review, so it's not going to be in geometry. But in Algebra 1, maybe you remember me doing this. I give you a set of parentheses. I give you a whole bunch of things to multiply, and then I put it to the 0 power. Well, you don't need to do anything. Anything to the 0 power, with the exception of 0 to the 0, is 1. That, ladies and gentlemen, is rule number 2 for exponents. Anything to the 0 power, with the exception of 0 to the 0, is 1. Not many questions. I'm going to go about this as quickly as you can. So if you have questions, you should be asking me. All right, rule number 3. This is paradoxically the multiplication rule, except the multiplication rule doesn't say to multiply. It says to add the exponents. Remember doing this last year? When you multiply like bases, notice there that's even outlined. The bases must be the same. When the bases are the same, you simply rewrite the base and then add the exponents. Yeah, that's it. Rewrite the base and add the exponents. But the bases must be the same. If the bases are the same, rewrite the base add the exponents. You've seen this before. Here's an example. Check it out. Look, the bases are the same. I've got a 3 as a base on this one, and I have a 3 of base as a base on the second one. Why are you not writing? There we go. When the bases are the same, you rewrite the base and add the exponents. 4 plus 8. Does anybody actually write this? Oh, heck no. Everyone just does that part in their head. But you have to make sure that the bases are the same. The bases are the same, you add the exponents, rewrite the base. Now, should you do 3 times 3 times 3 times 3 12 times? Well, there's no hard fast rule. For instance, 2 to the 4th or 5th power, yeah, you probably would rewrite that as 16 or 32. Is that right? 2 times 4, 8, 16, 32. Yeah, 64 would be 2 to the 6th. However, if it's 3 to the 12th, that's a pretty darn big number. No, you can leave that as 3 to the 12th. There's no hard fast rule, by the way. This also applies to not only numbers, but variables, as long as the variables are the same. Notice the bases here are the same. I've got an A and an A. So I rewrite A and add the exponents. Does anybody actually write this right here? Right, the middle thing? No, they just simply go from the start to the finish, and that's fine. You do have to make sure that the bases are the same. Since I've said that, I don't know, 6 times, well, what happens when the bases are not the same? Let's just investigate that briefly. When the bases are not the same, check it out. On this first one here, I got a base of 2 and I got a base of 3. And it turns out you can do nothing other than to expand and multiply. In other words, I can take 2 to the 5th, expand that one and multiply. I can take 3 squared, expand it and multiply. 2 to the 5th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th is 32. Well, 3 squared, that's the easy one, that's 9. By the way, this is not 6 to the 7th. Right? I shouldn't even put that. I'm going to confuse some people. But you can't just multiply the bases. You're not allowed to do that. You've got to expand and then multiply. We said 2 to the 5th was 32. We said 3 squared was 9. Whatever 32 times 9 is, that's your answer. I should not even write. I'm going to cause some people some problems, because this is all they're going to see. I see this on tests a lot, though. Somebody, one of you, will see that multiplication. You won't know your exponent rules, and will do this silliness right here. Please don't be that person. When the variables are not the same, you can't multiply them, right? You can't do x times x or x times y is xy, 5 plus 2 is 7. All you can do is just push those two variables together. Well, you really aren't doing anything here, right? There's nothing to do for x to the 5th times y squared. Nothing to do at all. Okay. Rule number 4. No questions I should ask. Rule number 4. There's 6 of these. We're going through these pretty quickly. Rule number 4 is called the division rule. And paradoxically, again, the division rule doesn't require you to divide, it requires you to subtract. Crazy. The multiplication rule says to add the exponents. The division rule says to subtract the exponents. It also says the bases are the same. So the bases, once again, for multiplication and division, the bases must be the same. Okay, let's see how that works. Are the bases the same? That's always your first question. Yeah, look, I got an x and an x. So the steps are rewrite the base is x, and subtract the exponent. How do you subtract them? It will always be numerator minus denominator. So in other words, 7 minus 3. 7 minus 3 is 4. Nobody actually writes 7 minus 3. They do that part in their head, unless it's really weird numbers. But that's how it's done. Now I'll just, for the 5th or 6th time, bases must be the same. This one sometimes causes problems. Let's see. Why does it cause problem? Because there's no exponent on the bottom, or is there? Well, remember. Give me a second. I got a 7th grader and need some help. One second. Okay, sorry for the delay. All right, we're back at it. All right, where do we leave off? Oh, yes. That power is 1. So, oh, I did it again. I'm sorry, guys. I told him the wrong time. I got to. Yeah, okay, we're good now. All right, so that power is 1. That was weird. E-learning. I've had my fill of it. We rewrite the base. That's 2. We do 7 minus 1 is 6. So we get 2 to the 6th power. 2's, unless it's like 2 to the 20th power. I mean, you can do this one pretty simple. 2 times 2 is 4. Times another 2 is 8. Times another 2 is 16. Times another 2 is 32. Times the 6th one would be what? 64. Okay. All right, so what happens when you have multiple things? Well, remember, like bases with like bases. So I can do the 2's with the 2's and the x's with the x's. I'm not going to do them simultaneously, one at a time. So let's see, how do we write that? Well, we write 2 as, let's see, top minus bottom, so 5 minus 2, and x would be what? 7 minus 3. 5 minus 2 is 3, 7 minus 3 is 4. So we get 2 to the 3rd, x to the 4th, right? 2 to the 3rd, 2 times 2 times 2 is 8. So we should probably write that as 8x to the 4th. Questions? You guys are being awfully quiet today. Questions? All right, we are on rule number 5. Rule number 5. Rule number 5 says the following. This is called the power to a power rule. And once again, this one ends up being when you would multiply with the powers. Multiply with the powers. So let's see. When you multiply with the powers, you rewrite the base and you multiply the powers, right? So how is this done? Well, when we have a number to a power raised to a second power, see, 4 to the 5th to the 6th power, we rewrite the base. The base is 4, and we multiply 5 times 6. Done. Can't make that one too challenging because it's not. This also works with variables. A to the 6th to the 2nd. Well, you rewrite the base, multiply the power. 6 times 2 is 12. Is it that easy? Yes, it is literally that easy. All right. One quick note before I move on here. There are a couple ones that have fractions tonight for homework. So for instance, if you have, I don't know, 1/2, let me see how it's written in the book. 1/2 to the 2nd raised to the 3rd power. Well, how would you do that? Well, 1/2 raised to the 2nd, well, we multiply the powers. So we rewrite the fraction. We multiply the powers. Let's see, 2 times 3 is 6. And then that 6 will go to both powers. You're like, well, what powers are you talking about? 1 is to the 1st power. 1 times 1 is 6. So we get 1 to the 6th over 2 to the 6th. You see what I did there? 1 to the 6th is, I should put some equal signs here. 1 to the 6th is 1, and 2 to the 6th we already did, which is 64. 1 times, it doesn't matter how many times you multiply 1 times itself, you get 1. Now they're going to make your life a little bit ugly, and they're going to throw some negatives in there, so we got to remember the negative rules as well too. All right, I said I would finally explain to you at some point why something to the 0 power is 1. Well, we're almost there. Let me do rule 6, and then we'll get to that last part. All right, so negative exponents. Yes, you can have negative exponents. Remember, the rule for negative exponents is that it moves position. If it's in the numerator, it moves the denominator. If it's in the denominator, it moves to the numerator, and you get rid of the negative exponent, make it positive, right? I'm not doing anything with A. Like A, if it's negative, stays negative. If it's positive, stays positive. But what I'm messing with is the negative exponent. So if the negative exponent is in the numerator, look at this one, it becomes now the denominator. If the negative is in the denominator, it becomes the numerator. We better see some examples, right? All right, so 3 to the negative 2. Well, let's see. Remember, we could write this if we wanted to as a fraction. So we know now that 3 to the negative 2 is in the numerator, and the exponent is negative, so it moves to the bottom, right? So we were left with 1 over 3 squared, which is 1/9. The question is, why is this the case? Hopefully your algebra teacher showed you this last year. Let's think about this. If we had, I don't know, 3 to the second over 3 to the fourth, well, using the previous rule for division, it says rewrite the base and subtract the exponent. So 2 minus 4, well, that's negative 2. So that gives us 3 to the negative 2, which we are claiming is 1 over 3 squared, which is 1/9. Now, why is that working? Well, hopefully your math teacher showed you this last year. The other way of thinking about this in blue is just to write it in expanded form. Well, that would be, let's see, 2 3s on the top, 4 3s on the bottom, right? 3 to the fourth would be 4 3s. And look what happens when we do canceling. 3 divided by 3 is 1. 3 divided by 3 is 1. We're left with 2 3s on the bottom. Notice that's why the answer is 1/9. Okay, so that's an explanation. Usually this is the one that kids need an explanation on. The rest they remember. But that's why negatives move positions. All right, let's do another one. Remember I said the -5, that's the base. It doesn't, you don't mess with -5. It's still -5. You're going to mess with the negative exponent. So the negative exponent means, well, remember, parentheses -5 to the negative third power really could be written as over 1. So when the negative exponents move to the bottom, that -5 still stays -5. That's the one that you don't mess with. Okay, so what do we do here? Well, we go back to our rule for negative inside parentheses, odd power. So that means we're going to get a negative answer here. So let's see, 5 times 5 times 5 is 125. So we get negative, what, 1/25, right? So yes, they will absolutely make your life into misery because they love to throw negatives to see if you remember the rules or not. All right, here's the one that where we have both a numerator and a denominator. Check it out. We got a numerator and denominator where the exponents are negative. What does a negative exponent do? Well, it flip-flops position. The top becomes the bottom. Now, because the bottom is also negative, the exponent, not the number, then the bottom now becomes the top. So it basically flip-flops position. So only thing you have to do here is flip-flop the numbers, get rid of your negative exponents. Remember, I never got rid of a negative base. The bases here are not negative, by the way. We can do that math. 4 squared is 16. 3 times 3 times 3 is 27. So we get 16 over 27. Algebra review. You did this last year. All right. Oh, I didn't give you the explanation of why anything to the 0 power is 1. Well, let's see. We know by the division rule. So let's try, I don't know, 2 to the third over 2 to the third. Let's see. The division rule, when the bases are the same, says subtract the exponents. So that would be 3 minus 3. Well, that's 2 to the 0 power, right? And my claim is it's 1. Now, why is it 1? Well, look what the original start of the problem was. You have a number over itself. 2 to the third over 2. Any number divided by itself cancels to a big honking 1. And that's why that answer is 1. Anything to the 0 power is 1, with exception of 0 to the 0 power. All right, so there is your bonus. There is your explanation of why that is the case. Tonight for homework, you have a, as they say in Italy, your homework is 1 through 24. Yeah, it's all of them. They will not take you that much time. If you have any questions on the rule, I would play the video while you're doing the problems itself. If you play the video while you're doing the problems itself, get to the, or fast forward to the, whichever, is it, method 1, 2, 3, 4, 5, or 6, get to one of those. And then look at the problem, look at how my explanation is. If that still isn't enough, send me a chat Remember, we will be meeting face to face finally on Monday. So I look forward to seeing you guys on Monday, and we'll pick it up from there and drive on to the end of the year. Have a great weekend and see you guys physically on Monday.